deviation and how that connects to a bell-shaped curve. Bell-shaped curve. So in order to do this, we need to do this. Bless you. Does that look like a straight line to you? Why can I not draw straight lines? Is that better? Okay. Okay. Now, let's draw a bell-shaped curve. Does that look like a bell? Haha, I did a good job. Anybody want to move up to the board, you can. Unless you're happy where you are and you can see. If you're happy where you are, clap your hands. Okay, one person is happy, that's good. Everybody else. So in order to start this thing, the first thing you need to know is, you know how yesterday I told you that x bar is your mean? Well, x bar is the mean of the sample. But then in today's PowerPoint, which we're not going to use, I'm just going to show you it after the lesson, you will see this. This is called mu, and mu is also the mean, but this is the mean of the population. So when we're talking about the mean of the sample, typically you will see x bar. And when you're talking about the mean of the population, typically you'll see mu. Regardless of which symbol you see, they both mean the average or the mean of the data. So, here's what happens when we put these things together. Right in the center, that is your mean. Sometimes you'll see it as x bar. Sometimes you'll see it as mu. And then also that means it's 0 standard deviation. Okay? 0 sigma, 0 standard deviation. Now what happens in a bell-shaped curve, and that's why we need things to be symmetric, is right about here somewhere. This is one standard deviation. So the way you get to this is you take your mean and you add sigma to it. And what does sigma represent? Your standard deviation. Now, if on this side you have your mean plus one standard deviation, what should it be on this side of your mean? Mean minus one standard deviation. And in statistics, what this is supposed to represent is that typically approximately 34% of your data falls between your mean and one standard deviation from the mean. And if 34% falls there, what do you think falls on the left side? Approximately another 34%. It has some decimals, but we're not going to get that specific. Okay? Now, what is this going to be if you go one more standard deviation to the right? Your mean plus 2 sigmas, 2 times the standard deviation. And on the other side, you're going to have minus 2 standard deviations. And approximately 13.5% of your data falls between 1 standard deviation to 2 standard deviation on either side. Approximately. What percentage are we on so far? What's 34 plus 34?
68.
68. 13.5 plus 13.5?
27.
And 27 plus 68?
95.
95. So what this says is that 95% of your data should fall somewhere between 2 standard deviations to the left and 2 standard deviations to the right of your mean. How much do I have left? So then what would this one be? X bar plus 3 sigma and X bar minus 3 sigma. And then in this slot here, it's approximately 2.35% and 2.35%. And then way out here in the tails, it's 0.15 and 0.15. And this is approximately. Okay? The exact values are a little bit different. It's like 0.13 something. But we're going to use these in our calculations. You'll be fine. So now let's see if you can apply this. Guys, suppose I tell you that we went through data and we did our study and we collected data and we found our mean to be 54. And suppose we calculated our standard deviation and we found a sigma of, let's just say, a whole number of 8. Can you guys please make a bell-shaped curve for that information? In your minds, I'll get you started. Probably not the best bell-shaped curve I could have drawn. But guys, what's right in the center of this bell-shaped curve? Say it again. 54. Very good. Does that get you started? Okay, so please go ahead and do the rest. I didn't do a really nice bell-shaped curve, so this is going to be kind of not good for me. I'm going to move a little bit so I can get... Alright, what should be to the right here? 62. What should be to the left here? Okay, and let's go one more here. 70, and let's go one more here. Okay, and then let's go ahead and go 3 standard deviations. And then let's go ahead and go 3 standard deviations. Okay. Any questions on where those numbers are coming from? Numbers came from? Okay, question for you. What percent of the people, let's just say this is a score. What percentage of the people scored between 54 and 62?
34%.
34% is exactly right. What percent of the people scored something between 46 and 62?
68.
68% is correct. How did you guys get this? Add them up. Now guys, the answers to these questions, are they coming from here? No, they're coming from here. So you have to know these percentages so that way you can answer the questions. What percentage of people scored higher than 62? Is it 16%? Yeah, I think it's 16%,
Yeah, it is.
correct? How are we getting that?
13.5 plus 2.25.
Yeah, this plus that. Okay? Now, please listen to the wording. Suppose there was 240 people in the study. How many people scored between 46 and 54? You will not be crunching this with your brains. You will take a calculator and you will crunch this. Calculate the number of people. And what did I say between 46 and 54? Okay? So what's the percentage between 46 and 54? 34%. And you're going to take 34% and multiply it by 240 people. Around 80 people. How many people were within 2 standard deviations from the mean? Okay, wording got tricky now. How many people were within 2 standard deviations from the mean? What does that wording get you to do? Well, what is within 2 standard deviations from the mean? How much is that? 95%. Do you guys see that? How much is it within 1 standard deviation from the mean? 68. 2 standard deviations from the mean should be 95. So here what you should have done is 0.95 times 240 people, which gives us what? 228? And there you go. Alright guys, that pretty much captures today's lesson. That's the relationship between your mean, your standard deviation, and a bell-shaped curve. And then, I don't know if you're familiar with z-scores. You guys know about z-scores? Well, z-scores is would be, you just use this, but then you just, instead of doing the numbers, you just do your standard deviations. But you guys don't have to worry about that this year. But if you knew about z-scores, it's all connected to the bell-shaped curve. All right, so I think that covers what I want to cover. I will show you some PowerPoint slides just to bring everything together. Does anybody have any questions for me? Yes?
So when you multiply the 0.34 and 240 and you get like 81.6, so you don't want us to round up just like to 82, you want us to go
Oh, I thought I heard 80.
Oh.
And then it's approximately 82
Right.
people, because you can't have 81.6 people.
Right.
But my third period were very, very mean. They said, what if you're a paraplegic or a para, you know, what is the word? Do you guys know what the word is, that big word? Yeah. Say it again. Anybody know it? Paraplegic. Yeah, that's what they said. And I'm like, that's not funny. They're like, well, if they're missing like 2 arms, then they're not a whole person. And I'm like, that is so wrong.
If you're pregnant, are you double people?
Whoa.
Exactly.
You have 2 brains.
Like what if you're like 6 months pregnant and it's 81.6?
There you go. You got your 81.66. Yeah, that would work. That's funny. All right. See, they were thinking negative.
Yeah.
Instead of missing limbs, you could have
More.
anything. All right.